Hello, pre-calc students. Today we're going to learn about polar coordinates. I love polar coordinates. They're kind of fun and they make really cool pictures when we start doing pictures. This is also section 8.1 in your book, so feel free to kind of look at that as we go along and look at their examples as well. So far in math, you've learned about the rectangular coordinate system. You've learned how to go up and down, left and right. So if you want to get to a point, it's defined by going right so many points and up so many points, and then that's how you get that ordered pair. But in polar coordinates, it's defined by how far away is it from the origin and then the angle that you go around. So it's a lot more like unit circle amounts than left, right, up, and down. So r is defined as the distance from the origin. I think of it as a radius because to me it's like a radius going out from the center of the circle, but it's not technically a radius. And theta is like a unit circle angle. This is what a polar coordinate graph looks like. So if I wanted to go to the point, let's say this one right here, I would count how many units I am away from the origin. So let's see if I can make this work. Here, whoa, where did that go? Let's ignore that. Sorry, going out 1, 2, 3. So I've gone out 3 units away from the origin, and that angle, I know it's been a while since we've done unit circle stuff, but that angle is pi over 3. You can go positive angles, which is going counterclockwise, and you can go negative angles. So going down this way would be a negative angle. You can also have your r's be negative as well, and it would be going the same amount in the opposite direction. So I can show you that in a few examples. So my first example here is 1, then pi over 6. Usually I like to go the angle first just because that's what I'm used to. Okay. Go pi over 6, and then you're going to go out 1, so that point would be like right there. I can't get that to work for some reason. That angle, go out 1. So that is that point right there. 3 negative 5 pi over 6 would be going backwards all the way to here. That's negative pi over 6, and then go out 1, 2, 3 units. That would be that point right there. The only reason I'm drawing open circles is my pen won't let me actually draw on here. Okay, and then this crazy one is negative 4, 101 pi over 2. So if you think about it, I don't want to really go around and spend all of my time on my video going around 101 pi over 2, but for every time I go around, I'd be going 2 pi, 4 pi, 6 pi, 8 pi. So if I went 100 pi over 2, that would be 50 pi, which would mean I'd end up going around and around and around. I don't want to go like that, but then we're going to go here, and then I'd still have a half of a pi over 2 to go, 1 pi over 2 left to go. So that would be up here. The negative means instead of going up positive, you're going to go back 1, 2, 3, 4, and your point would be down here. At this point, I would ask if there's any questions. You guys probably wouldn't ask any questions anyway, but you can ask questions on Google Classroom if you'd like to try to figure those out. Another way to just get used to polar coordinates is to figure out that there's an infinite number of ways to write this point 2 comma pi over 3. So going to pi over 3 and then go to 2, that would be this point right here. But there's a lot of different ways I could write that. I could go around the circle one more time. So that would be 2, and then that would be 7 pi over 3 because that's going around another 2 pi, and I could go around another 2 pi and say that it's, let's see, 6 pi over 3, so that would be 13 pi over 3. But you have to realize I can also go backwards. So I could say that this is the point 2 comma negative 5 pi over 3. I could also use the negative numbers, so I could go to this angle right here, but then go backwards too. So I could do, well, I'm doing both negative, so negative, let's erase that. -2. And then let's see, what is that angle? -2 pi over 3. I know it says give two others, but I'm, like to overachieve. And then we have -2. We could also go this way to get to that same angle and then do -2. So what would that be? That would be 4 pi over 3. So there's a lot of different ways to write the same point. Okay, all of these all these equations, all come from one basic triangle. You could draw this triangle in any quadrant, but it's always easier to work in the first quadrant. So it's all based on this equation. These should look familiar to you from vectors because that's why these are in the same chapter with vectors. Not that they're really related, but they're related by these equations. So if you solve this triangle with cosine, you would get cosine of theta equals adjacent over hypotenuse, x over r, and that's how you get this equation. You could do the same for y and sine. So these two equations are extremely important in polar coordinates, going back and forth between rectangular and polar. Remember, rectangular are the ones that you learned about in basically grade school. And then this one is the Pythagorean theorem, x squared plus y squared equals r squared, and then tangent of theta equals y over x. So you're going to use the first two when you have polar coordinates and you want to change them to rectangular, and you use the second two if you have rectangular coordinates and you want to change them to polars. But these are the four main equations that you're going to use to deal with polars and going back and forth between rectangular and polar coordinates. So I have this 0.6 2 pi over 3. In order to change this, so first of all, get an idea of where it's at. 2 pi over 3 is over here, and we're going 6 units out. So this distance is 6, and this angle is 2 pi over 3. So it should be a second, it should be a second quadrant rectangular point when you do this one. To find them, your x is going to equal 6 times the cosine of 2 pi over 3, and y would equal 6 times the sine of 2 pi over 3. Luckily, you all still remember your unit circle, so you can figure that out easily. If you could see me right now, I'd be doing the hand jive. The cosine of 2 pi over 3 is -1/2. And the sine of 2 pi over 3 is positive, because we're in the second quadrant, square root 3 over 2. So that would be -3, and then this would be 3 square root of 3. -3, 3 square root of 3 would be what this is in rectangular. So I could go the polar way of going around the circle 2 pi over 3 and then going out 6 units from the origin, or I could go -3 over and then up 3 square root of 3 and get the answer as well. It will work, for 5 pi over 2. Let me see. Let me try to draw a line here. 5 pi over 2, it will still work. So you have -1 times the cosine of 5 pi over 2, and y is equal to -1 times the sine of 5 pi over 2. So the cosine of 5 pi over 2 is around the unit circle once. That's 4 pi over 2, and then it's back up here. The cosine of that is 0. So this would be 0. And then the sine of that is equal to 1. So you would have the point 0, -1. Now I'm pretty sure without doing those fancy equations, you could have still figured out that going around the unit circle, oh wait, that says -1. Let me fix that. I have the right ordered pair down there, but I don't have the right thing. So we would go around to here, but then we would go back 1 unit this way, and your point would be down here. I'm pretty sure most of you could have figured out that that is the point 0, -1 without using those two equations, but those equations still do apply. So let me take a little break here and